Hello, I am Shane Brinkman Davis Delamore, and this is Code and Optimism, a show where we explore how to solve problems faster with software. Today is going to be the second episode on this big topic of modular design. And here we're going to introduce the 5 essential elements of good modular design. We're going to dive into that a little bit. We're going to go through each of them briefly. And then in subsequent episodes, we're going to dive into each of them more deeply. So let's just start at the top here. I want a little bit of a recap from last time. Why modules? Why do we care? So all of this stems from solving problems faster with software. That's what we're here to do. That's what we're trying to understand. And this really subsumes, in my opinion, all of software engineering. Everything is about how do we solve problems faster. Everything else is just requirements that we have to solve them faster. The problem is when our projects get bigger, complexity in the natural state of our code will scale exponentially with code size. So you double your code size, you quadruple the complexity. And as our projects get really big, that means that our velocities can get really small. So we want to accelerate big projects. We want to solve problems faster. We have big things to solve. We need to manage that complexity. And modules are how we can do it. Because essentially what modules let us do is they let us make our code small again. It allows us to take a big project with 100,000 lines of code and shrink it back down to a 10,000 line of code project. So now, given that context, let's take a look at how we make good modules. A while ago, I was trying to explain modular design. I don't remember exactly the context. So I went searching on the internet. I tried to find a good article on how to do good modular design, and I just couldn't find anything out there. And so I just started thinking out my own experience and what works well and what doesn't, what's important. I play around with ideas, and I eventually settled on these 5 elements: purpose, interface, encapsulation, connection, and implementation. And I wrote a blog post to it. I'll link down below. We'll also put a link to the previous episode. And I ended up with this sort of sense that these are all elemental. They're all essential to good modular design. You can't do a good module without all 5 of these. If any one of the 5 is not good, it's going to kind of break the other ones. So they're all interconnected, and there's definitely fuzzy lines between all of them. But there's also enough distinction, I think we can talk about each 5 of the 5 separately. So let's just go through the list. We're going to do a very cursory step through each of these and how they fit. And then next time, we're going to dive in deeper. So first is purpose. Purpose is the reason your module exists. Your module is a product. It has a vision. You should have an elevator pitch, a 1-sentence description of what your module is that you can tell someone in just that short amount of time, and they can understand why it exists and what it's trying to do. The reason why you need a good purpose, and you need to be as focused as possible, as singular as possible, that is going to impact how you make all the other decisions about designing this module. If you've got a very clear vision, a very clear understanding of what is part of this module and what should not be part of this module, it makes all the other parts much easier to make good decisions about. It also allows your clients of your module to know how to use it much more effectively. Purpose is critical. Having a clear, focused purpose matters. So you want to maximize the focus. Next up is interface. Now the interface is the interface between your module and the rest of the world. The clients are going to use your module. And your interface needs to be as small as possible. You want to minimize your interface. You want it to make it as easy to use and as easy to understand and as few moving parts as possible. This is critical because this is how you're going to make your code small again. You're basically going to, from the point of view of the rest of your app, delete all the code that's moving into your module. It's going to disappear from the rest of your app. All that's going to remain is this interface. If you make this interface big or complicated and hard to understand, you're still going to have a lot of big complication in the rest of your app. If you make this interface small and tight and clean and easy to understand, then you have won in terms of shrinking the code size of your main project. Encapsulation. This is the flip side. So you want to have this interface, and then you want to encapsulate all of that complexity to support that interface behind a maximum power shield. You want to maximize the privacy of your module. So the more things you can make private inside your module that cannot be touched or interacted with from the outside world, the more you've reduced the code size of your project you're making this module from. This is critical. You want to minimize your interface and maximize how much you're encapsulating and isolating all of the implementation inside. This is, again, how you can manage the complexity, because you are essentially like, if you take your project and you split it from one module into two, you're cutting it in half. And you're putting half in one module, which is halving its size in, how do you say, one quarter of it. You're making its complexity 1/4 of what it was. And then you have an interface between them, and now you've managed your code size. Connection. So now this is a bit of a context. So we just talked about the purpose interface encapsulation part, which I call the pie of our 5 parts. That's really just looking at the module itself and making sure you have a good little module. But your module doesn't exist in isolation. It works within an ecosystem. So connection is of the modular hierarchy, it's the modules above and to the peer of your module. It is the context in where your module is going to get used. You want to set it up so that that ecosystem has the minimum amount of intermodular interdependencies. Because after all, we're trying to minimize complexity, and complexity comes from all the cross talk between modules. So you want to think about, how do different modules need to connect to each other in order to use our module? Similarly, in the implementation inside our module is going downstream in the modular hierarchy. Because at the end of the day, every module is just built up of other modules. And within your implementation, you want to have the bare minimum necessary to deliver your interface, or the requirements of your interface. You want to simplify the implementation, and your implementation ultimately is a bunch of connections of modules within it. You want to minimize your downstream dependencies and keep it simple, clean, and reliable. So that is it. That is the 5 essential elements of modular design: purpose, interface, encapsulation, connection, implementation. As an acronym, I think of it as PI-CI. That's how I remember it. And it's easy as PI-CI. And we're going to go into each one of these in a little bit more detail. I am curious at this high level if you see any gaps, if there's aspects of good modular design that you can think of that you think that doesn't really fit in any of these 5 categories. I would love to hear from you. Send some comments down below, and let's have a conversation about this. Next time, we will dive into purpose. So with that, I will thank you so much for spending your valuable time with me. And remember, all problems are solvable with enough knowledge.